Hi, welcome to this video. In this video, I'll be sharing about what a capacitor is and why do we need it, how does it work, and all the little details that go into it. If you do like the video, share it with your friends so that all of your friends can get the clarity on this topic and you guys can discuss it better and improve your thinking in the process. Do subscribe to the channel so that you get to know when we are launching the videos next. So let's get started. I'm Atray from Cosmic Essence, and get your notebooks out so that you take proper notes. Okay, so first things first, let's talk about a capacitor, and let's first discuss what is it made up of. So capacitor in its most general form is essentially two conductors, conductor 1 and conductor 2, separated by a small distance between them, having charges on them. Usually we want the charges to be opposite to each other so that they stay together, and when we pull them apart there is a slight potential difference. So this is a system of capacitors where two conductors which are charged oppositely are separated by a small distance between them, right? That means this conductor can have any shape or size, right? It does not matter what shape or size this is. This system, whenever present, is called a capacitor. Now, an edge case of the system, is also that a single conductor can also be considered a capacitor. How? We can think of the other conductor, the second conductor, as at far off, at infinity. So when we think of it that way, we can say that even a single conductor can be thought of as a capacitor. Very fascinating, but that is how definitions work and that is how theory works. So it's very interesting to understand this. Now in our case, because we are doing high school level physics, so in our case we only take a particular case of capacitors which are called parallel plate capacitors. So parallel plate capacitors are shown like this, where these are two metal plates that are conductor plates separated by a small distance d, with one charged positively with a fixed charge, say q, positive q, and the other one is charged negatively with an equal charge minus q. Okay, this is how this is what we call, the system is what we call a parallel plate capacitor. Now why is this important? Because it simplifies a lot of complexities that we do not want to get into right now. It simplifies because if we had two conductors, the charges on the two conductors can be different, but here we are taking the magnitude as the same, that is both have q charge but obviously oppositely charged. So that makes it that much more simpler, and we are taking like big plates like this because it helps us in creating an ideal atmosphere and surrounding. So I will be covering that in the next video, so you can always have a look on the channel for that video. Now here, how does a capacitor work? Let's understand that. What is happening when I connect it with a battery? When I connect it with a battery, what is happening is the battery is giving it a charge like this. Now what is actually happening is the electrons which are moving this way, right? Because remember, we take the positive, the current is taken as the positive side, but it is actually the electrons that are moving across. So the electrons are moving this way, and when they reach here, to take them across this gap, this is like a valley, okay? To take them across this gap, someone needs to push them. And who's going to be pushing them? Obviously the provider of energy, which is the battery. So what is happening here, to travel till here through the wire is very simple. No one the electrons do not need a push at much, but from here to here this electron needs a push. It needs a push, and we slowly push it. We slowly push it as it reaches a higher potential. As it reaches a higher potential. So it reaches a higher potential at this point. So if here V is A, that is the electrostatic potential is VA, here the electrostatic potential is VB, then VB is greater than VA. Why is that? Let's understand. Think that we are trying to roll up a stone up the hill, right? Think of it as rolling up a stone up the hill. This is point A, and I slowly start pushing this stone up. As I start pushing this stone up, what is happening? Here the potential was low, but because of the height, the potential over here is higher. So when the stone gets here, the potential over here is higher. And how much potential is stored in it? The amount, that is the work done against gravity, which gets stored in it. So here the work done against the electric field, gets stored as we reach the point B. And electric field is of course from positive to negative. That means the direction of electric field is this way. So as I am taking the electron from A to B, clearly you can see that I am pushing against the electric field. Very important to understand what is happening inside. Okay, so think of it like taking a stone and pushing that stone up the hill as we increase its potential energy, right? So this is what a capacitor is all about. Now why do we need it? Because in this way what we do is we can charge a capacitor, right? So what is happening when we start? Think that we are starting. As we start, the two plates are uncharged. Now due to the battery, the electron will travel and it will create a negative charge over here. But at the same time, due to this negative charge, there will be an induction. That means it will repel the electrons from here, right? So due to induction, this negative charge will repel all the electrons from this plate, and the electrons will start going and they will essentially reach the battery back. But this creating a positive charge here. And how much will be the positive charge? Obviously equal to the negative charge we had on the initial plate. Okay, so that is how a capacitor gets charged.